Hello, this is Mr. Collier, and today we're finding the gradient of a curve at a given point. Okay, so the gradient of curve at a given point is actually the derivative of the function at that point. It's the same as the derivative of function at the given point. Okay, so we're going to be doing that. We can do it by hand, and we're also going to be doing it with the calculator. So let me just show by hand first. So in the first function, we're going to get the derivative. The derivative is 12x, and then you differentiate the constant, you just get 0. So the derivative is just 12x. So if you want to find the derivative when x equals 2, you just substitute in x equals 2. So the derivative of the function at, actually I should write it, derivative of the function at x equals negative 2 is 12 times negative 2, which equals negative 24. Okay, and that also means if you were to draw the function, then the slope of the tangent line at x equals negative 2 is negative 24. Okay, so we're going to show that with our calculator right now. So on your calculator, you type in the, let me put this right over here. So we're going to use this function. So we go to math, and then if you scroll down, you'll see derive, or if you just press number 8, you'll get this derivative function right here. Okay, so we're going to be differentiating with respect to x, so that's going to be d by dx. Here you type in the function, so our function is 6 x squared plus 6. So that's our function, and then over here we have to type in the value of x. That little box, so our value of x is negative 2. Okay, so then I press enter, and you get negative 24, so that's exactly the same as when we worked it out. Okay, so this calculator feature is going to work for, this is a simple function, very easy to do by hand, but if you have a very complicated function, the calculator is going to make it a lot easier for you. Okay, and the next one, let's try it by hand, and then with the calculator we have f of x, the derivative, sorry, f prime of x equals 15x squared minus 4. So then we're going to find the derivative at x equals negative 1. So we substitute in x equals negative 1. And then we get, okay, 15 minus 4, which equals 11. So the derivative at x equals negative 1 is 11. You can think of that graphically as, a cubic function. Maybe it's going to look something like that. But at x equals negative 1, the slope of the tangent line equals 11. Okay, so now let's do it with the calculator. Alright, so we're going to go to math and press 8 for derive. And this is differentiating with respect to x. Then we have 15x, sorry, I typed in the wrong function, 5x cubed, and 5x cubed minus 4x. And we're deriving, or we're finding the derivative at the point x equals negative 1. And we get, good point, we get 11.000. So the calculator uses estimating methods to find a derivative. So if you get something like this that's very, very, very close to 11, then chances are the calculator made a slight estimating error, so it should be exactly 11, and that matches what we did by hand.